Hi students, welcome to today's class. So in this video, I am going to explain very important problems which were given in previous JEE mains examinations. I selected a good number of problems which are very thought provoking and very easy problems also. Okay, let us see that problem. Welcome to this problem. So it is given that f of x be a polynomial of degree 4 having extreme values at x is equal to 1 and x is equal to 2, and if limit extends to 0, f of x by x square plus 1 is equal to 3, then f of minus 1 is equal to how much? So first of all, it is given that the polynomial has degree 4. That means let the polynomial be f of x is equal to ax to the power of 4 plus bx cube plus cx square plus dx plus e. Okay, now let the polynomial be. So first we will make use of this condition. So what is that? Limit extends to 0. So this, what is the f of x means ax power 4 plus bx cube plus cx square plus dx plus e, a b c d e, divided by x square plus 1 is equal to 3. So wherever f of x there, I have substituted that polynomial. So this is equal to limit extends to 0. So divide with x square each and every term. So this is equal to ax square. So this is a bx plus c plus d by x plus e by x square plus 1 is equal to 3. Okay, now. So if you observe here, this is a finite value, 3 is a finite value. So total this limit value will be finite. So this is possible only when this d value should be equal to 0, e value should be equal to 0. Why? Because as x tends to 0, 1 by x tends to infinity, 1 by x square also tends to plus infinity. Okay, now that's why d value, e value should be equal to 0. So I will write down d is equal to 0, e is equal to 0. Okay, now. Now as x tends to 0, now substitute. So a into 0 square, 0, b into 0. Therefore, what we will get? C plus 1 is equal to 3. C plus 1 is equal to 3 means, so this implies c is equal to 2. Therefore, we got c also, c value also we got 2. Now let us make use of this first given data. That means the function has extreme values at x is equal to 1 and x is equal to 2. What is the meaning of that? That means, let us draw the graph of x-axis and y-axis. X is equal to 1 and x is equal to 2. It has a extreme values means what? So that maybe the graph may be upward or may be downward at the point. Extreme values means what? Maximum or minimum. At x is equal to 2, the graph maybe takes upward or maybe takes downward, we don't know. That means at that extreme points, if you draw a tangent, the tangent will be parallel to x-axis. So since tangent is parallel to x-axis, what is the slope of x-axis? 0. Therefore, slope of tangent is equal to 0. Therefore, f dash of x is equal to 0. That means what? F dash of 1 is equal to 0, f dash of 2 is equal to 0. F dash of 1 is equal to 0, f dash of 2 is equal to 0. Understand? So that is the thing what we have. Now what is f dash of x? So this is a f dash of x is equal to, this is a 4a x power 4 derivative 4x cube. So 4x cube. So this is a 3b x square plus 2cx plus d is equal to 0. Already we know that d value, e value, c value. Substitute here. Here d value is 0. So this is a 0. A value, so f dash of 1. F dash of 1 you substitute. F dash of 1 means substitute 1. So this is equal to 4a plus 3b plus 2 into c value we got, that is a 2 into 1 is equal to 0. Understand this. X value we have substituted and c value also has substituted too. So this is equal to 4a plus 3b plus 4 is equal to 0. Call it as equation number 1. Okay, now Again f dash of 2 is equal to 0. Let us substitute that and we will get an equation in A and B. Let us solve that A and B, those two equations, and we will get A value and B value also. Okay. So let us continue the calculation. Welcome back to the remaining calculation. So here we have f dash of 2 is equal to 0. F dash of 2 is equal to 0. So this is a f dash of x 2 cube 8. 8 4s are 32. 32a plus 2 square 4. 4 3s are 12. 12b. X value is 2. So here 2, C value 2, X value 2. C value 2, X value 2. 2 2s are 4, 4 2s are 8. So this is equal to 8. So is equal to 0. Call it as second equation. Okay now. Now let us solve these two equations to get the second equation you can divide with 4. So here 4 8s are, 4 3s are, 4 2s are. Call it as this as a second equation. 4 8s, 4 3s, 4 2s. Now let us solve these two equations. Let us subtract here. So here why? Because here 3b is there. So therefore 8a minus 4a, this is a 4a. 2 minus 4 minus 2 is equal to 0. From this a is equal to 1 by 2. So substitute a is equal to 1 by 2 here. So we will get here 1 by 2 means 2 plus 3b plus 4 is equal to 0. So therefore b is equal to 2 plus 4 6. So minus 6 by 3. Therefore b is equal to, we will get minus 2. So all the values we got, A value we know, B value we know, already C value we know, D, E value know. Let us frame the polynomial and substitute f of x is equal to minus 1. Okay now. So let us continue the calculation. Welcome back. So what is our polynomial? A x to the power of 4, 1 by 2 x to the power of 4 plus b x cube minus 2 x cube c x square. So that is equal to 2 a, B, C, x square. Understand this? Ax power 4, x cube, x square. A value, B value, C value. D value, E value becomes 0. So forget about that. So therefore, f of minus 1. So f of minus 1, this is a minus 2. So this is 1 by 2 minus 2. So minus 1 whole square means this is a plus 2. So minus 1 whole square means 2. So therefore, 2 plus 2, 4. 2 4s are 8, 8 plus 1, 9 by 2. Therefore, option D is the correct answer. Understand? So, I hope that you enjoyed this solution. Let us move to next problem. Welcome to this second problem. If f of x is equal to 3x to the power of 10 minus 7x power 8 plus 5x power 6 minus 21x cube plus 3x square minus 7, then limit extends to 0. Alpha tends to 0, f of 1 minus alpha minus f of 1 by alpha cube plus 3 alpha value is equal to how much? We are asked to find out this value total. So there is a finite answer is there. Then how to do? Yes, first as alpha, let us see the solution. As alpha tends to 0, wherever alpha is there, substitute 0. So 1 minus 0, 1. So f of 1 minus f of 1 definitely 0. Wherever alpha is there, substitute in the denominator, we will get a 0. Therefore, 0 by 0, which is a indeterminate form. So, we can go for L'Hopital rule. Okay. So, what is the L'Hopital rule? So, differentiate the limit alpha tends to 0. So, here, so f of 1 minus alpha. So, what is the derivative of f of 1 minus alpha? F dash of 1 minus alpha minus alpha with respect to alpha we are doing. So f dash of 1 minus alpha, this is equal to minus 1. F of 1 will become a constant 0. Alpha cube 3 alpha square plus 3. Understand? 3 alpha square plus 3. Now you substitute wherever alpha is there, substitute 0. So we will get this is equal to f dash of alpha, you substitute 0. This is equal to f dash of 1 by 3 we are getting, f dash of 1 by 3. Alpha is equal to 0, substitute here, f dash of 1. So of course here minus is there, minus f dash of 1 by, here alpha is equal to 0, 3. So if you find out f dash of 1, the problem will be over. Now substitute f dash of 1 means what? First find out f dash of x. So this will become 10x to the power of 9. 7 8s are 56 x to the power of 7. 5 6 are 30 x to the power of 5. So this is equal to 63 x square. X cube means 363 x square plus 6x. Okay now, right. F dash of 1, wherever x is there, substitute 1. So this is equal to 10 minus 56 plus 30 minus 63 plus 6. Okay, let us see this, how much it is there. So this will be minus 53. So this will be minus 53. So let us check here. 10 plus 30, 50, 50, 10 plus 30, 40, 40 plus 6, 46. So here minus plus 10 will be there. So minus 63. So if you subtract minus 10 will there. So minus 53 we will get f dash of 1. So therefore now substitute here. In this substitute if we get so minus of minus plus 53 by 3. Therefore option B. Let us check this calculation. So here once you check x power 10 derivative is 10. 10 already 3 is no. So here you will get 30. So here we will get 30. Okay now. So 30 plus 30. 60, 60 plus 6, 66. So here 66 minus 56 minus 63. So this is equal to 109. So if you see this calculation, 7 8s are 56 x power 10, 5 6 are 30. So minus 63 x square plus 6x. So here 30 minus 56 plus 30 minus 63, last one 6. So let us see that, yes, we are getting minus 53. So this is the calculation. So minus 53 we will get here. So minus of minus 53 plus 53 by 3, then we will get the answer. Option B will be the correct answer. Okay now. So I hope that you understand this solution. So let us move to next problem. Hi students, welcome to this problem. For each t belongs to R, let step of t be the greatest integer function less than or equal to t. That is a well known. Limit extends to 0 plus x times step of 1 by x plus step of 2 by x plus so on step of 15 by x is equal to how much? So options are also readily available. To solve this problem, the first thing what you have to know is step of x is equal to x minus fractional part of x. Step of x is equal to x minus fractional part of x, where this fractional part lies between x here lies between 0 to 1. It may be 0 or but strictly less than 1. This is the fractional part of this. This is the first property we have. Now coming to the problem. So this is a limit extends to 0 plus x into step of 1 by x means what? So this is a 1 by x minus fractional part of 1 by x plus 2 by x minus fractional part of 2 by x plus so on 15 by x fractional part of 15 by x. Okay now. So by definition, so with that step function is avoided. So avoided. So okay, now coming to here. This is equal to limit extends to 0 plus x into, see here. So let us arrange grouping the like terms, grouping the terms here. 1 by x plus 2 by x plus so on 15 by x. So this is equal to 1 by x plus 2 by x plus so on 15 by x as a one group minus fractional part of minus 1 by x minus take the common outside. So this is a 1 by x plus 2 by x plus 15 by x. Okay now, right. So just we group the terms. Now one thing is very clear. Step of fractional part of x lies between 0 to 1. Not only that. So fractional part of whatever may be that r by x is also less than 1. Fractional part of whatever may be less than 1. So, even then you multiply with any x, even then you multiply. So, fractional part of r lies between 0 to 1. So, whatever may be that, even though if you multiply any number to that, so that means 0 less than or equal to r by x, sorry, you multiply with x less than x. Understand this? So, multiply, that means fractional part of x into r by x lies between 0 to x. Understand this? So, here, so this is a limit. Now, if you apply, multiply x for both the terms. So, this is equal to limit x tends to 0 plus x into, so let us take the x common here. So, here common x 1 plus 2 plus 3 so on 15 minus limit x tends to 0 plus r into, sorry, x into, so here x is there now. So, this is x into this whole thing, let us call it as r by x, r where r we can call it as a sigma, r runs from 0 to r runs from 0 to 15, sigma r runs from 0 to 15, we can say that, we can put it sigma r runs from 0 to 15. Okay, now, right. Now, if you see here, consider here, this value lies between 0 to x, the value lies between 0 to x, and this fractional part r by x now lies between 0 to 1 means what? 0 to 1 means what? 0 point something, 0 point something, 0 point something. Whatever may be the value, this value lies between 0 to 1. Total, the sum of these values lies between 0 to 1. X tends to 0, already x value is 0. 0 into 0 values between 0 to 1, how much? So, this is a 0 into the values lies between 0 to 1. Total, this will become 0. Understand this? So, coming to here, x will get cancelled. Why? Because as x is approaching to 0. So, therefore, x cannot be equal to 0. Therefore, we can cancel x. 1 plus 2 plus 3 plus so on 15, sum of the first 50 natural numbers, nothing but 15 into 16 by 2. That means n into n plus 1 by 2. So, 2 1s are 2 8s are 120. So, 120 is the correct answer. Okay, now. So, here you must be very careful. Why? Because if you add all these fractional parts, they will lies between 0 to 1. 0 to 1 means what? Less than 1. 1 means what? 0 point something, 0 point something, like that we will get. You are multiplying with x. Already x value approaches to 0. That means 0 into 1 finite value you will get. So, it is not infinite value. 0 into 1 finite value. Whatever may be that, this is 0 point something you will get finite value. Therefore, 0 into 1 finite value is 0. So, this will become 0. Here x you can cancel here. Why? Because here x approaches to 0 from right direction. It is x is not taking to 0. Understand this? That's why you can cancel x. Therefore, answer is 120. Okay. So, I hope that you understand this solution. Let us move to next problem. Welcome to this problem. F is a function from R to R, be a differentiable function satisfying f dash of 3 plus f dash of 2 is equal to 0. Then what is the value of limit x tends to 0, 1 plus f of 3 plus x minus f of 3. So, I am writing very clearly here. So, limit x tends to 0, f 1 plus f of 3 plus x minus f of 3 divided by 1 plus f of 2 minus x minus f of 2 whole power 1 by x. So, first of all substitute wherever x is. So, you call it as some I. So, where limit x tends to 0, wherever x is there, substitute 0. So, here 0, 0, 0. So, 1 plus f of 3 minus f of 3. So, these two will get cancelled. F of 2 minus f of 2 also will get cancelled. 1 by 1, 1. So, this is equal to 1 to the power of infinity. As x value approaches to 0, 1 by x value approaches to infinity. So, this is a 1 to the power of infinity type of problem. Then, how to find out this? So this is given by e to the power of, you have to raise e to the power of total function, we will put it as a minus 1, that 1 by x power, whatever we put in the power 1 by x, it will become a factor. Okay. So we will call it as a I1, that function. That I1 I am writing separately. What is that I1? Limit extends to this, so 1 by x will come forward, limit extends to 0, 1 by x into 1 plus f of 3 plus x minus f of 3 divided by 1 plus f of 2 minus x minus f of 2 minus 1. This is whatever may be in the e power value is this. So let us find out this value and substitute in the I1, we will get the remaining answer. So now let us do the LCM here. So limit extends to 0, 1 by x into, so if you do the cross multiplication, 1 plus f of 3 plus x minus f of 3 minus 1 minus f of 2 minus x plus f of 2 whole divided by 1 plus f of 2 minus x minus f of 2. Okay, now. So I have did the cross multiplication. Right, anything? Okay, so any more cancellations? Yes, we can cancel here. Plus 1 minus 1 we can cancel here. So if you observe, as a limit extends to 0, so here wherever, so up to here separate here, 2 minus 0, 2, f of 2 minus f of minus 2. These two will get cancelled, you will get 1. Therefore, this total value is equal to 1, up to that only. So what are the things remains here means, so f of 3 plus x minus f of 3 minus f of 2 minus x plus f of 2 by x is there. Okay, na? So let us calculate up to that. So let us continue the solution. Welcome to the remaining calculation. So see here, as x value approaches to 0, substitute here 0. This is f of 3 minus f of 3 minus f of 2 plus f of 2. So plus f of 3 minus f of 3 will get cancelled, minus f of 2 plus f of 2 will get cancelled. So we will get 0 by 0 form. So then we will apply the L'Hopital rule. So what is the L'Hopital rule? So this is equal to limit x tends to 0. This is a f dash of 3 plus x, again 3 plus x derivative is 1. Minus f of 3 derivative is 0. So this is equal to f dash of 2 minus x. Again 2 minus x derivative is a minus 1, already minus is there, plus 1 divided by 1. F of 2 derivative is 0. Now substitute wherever x is there, substitute 0. This is a f dash of 3 plus f dash of 2. So this already f dash of 3 plus f dash of 2 is given as 0. Okay, now. So let us see this. This is our I1 value. So total our I value is what? E to the power of I1, just e power 0. E power 0 is equal to 1. Therefore, option A is the correct answer. Okay, now. So I hope that you enjoyed this problem. So let us move to next problem. Welcome to this problem. If alpha, beta are the roots of the equation, then what is the value of that? So by seeing this value, so don't be get tension or afraid. Limit n tends to infinity, sigma r runs from 1 to infinity alpha to the power of r, plus limit n tends to infinity, sigma r runs from 1 to infinity beta to the power of r. Okay, now beta to the power of r. So first let us simplify that what is that expression. So by properties of limit, we can write that as a limit n tends to infinity, sigma r runs from 1 to infinity alpha to the power of r, plus sigma n tends to infinity, here r runs from 1 to infinity beta to the power of r. First of all, that means we can make it as a single limit. Again, by the properties of this sum notation, we can write down r runs from 1 to infinity alpha power r beta power r. Okay, now. So we have to find out alpha power r plus beta power r. So alpha power r means what here? So otherwise we can put it as a, so here r power 1 plus r square plus r cube plus so on infinity, plus Here beta power r means what? Beta plus beta square plus beta cube plus so on infinity. So on infinity. So this is a one box and other one box. So if you observe here, it is clearly a infinite geometric progression, but we have to decide r value, modulus of r value should be less between 0 to 1. Here also modulus of beta value should lie between modulus of x. So sorry, r value should lie between 0 to 1 and beta value also should lie between 0 to 1. Okay, now, so that we have to decide first of all. So for this it is given that alpha, beta are the roots of this equation. So that's why we know that sum of the roots is equal to minus b by a, that is equal to 25 by 375. Product of the roots is equal to c by a minus 2 by 375. See these values. Sum of the roots alpha plus beta is equal to 25 by 375. Product of the roots is equal to minus 2 by 375. So this is a proper fraction. This is also a proper fraction. So if you see these two, definitely by seeing these values, we can say that 0 less than alpha less than 1. Sorry, here alpha and beta values modulus of alpha. So that is equal to modulus of alpha less than 1 and modulus of beta less than 1. That means minus 1 less than alpha less than 1, minus 1 less than beta less than 1. So if you solve this separately, so we will see that the alpha value lies between minus 1 and plus 1, beta value lies between minus and 1. Therefore, this is an infinite geometric progression. So what is sum to infinite geometric progression formula? A by 1 minus r. So therefore, this is equal to a by 1 minus r. A means your first term, r by 1 minus r into, so this is equal to beta by 1 minus beta. A by 1 minus r. R means what? Common ratio here. A means first term by 1 minus beta. So this is equal to alpha beta by, so if you multiply 1 minus of alpha plus beta plus alpha into beta. Now substitute this alpha into beta is minus 2 by 375, alpha plus beta as a 25 by 375, again alpha into beta as minus 2 by 375. So after simplification, you will get the answer 1 by 12. C is equal to 1 by 12 value, you will get the answer. Okay, so first thing is by you can write there this and you expand it. So this is an infinite geometric progression. This also an so here plus, we got here plus, here one more correction here. So here not here, plus is there, plus. That's why then we will get here option. So here this is equal to alpha minus alpha beta. So this is a beta minus alpha beta by, so this is a 1 minus alpha plus beta plus alpha into beta. So this is equal to alpha plus beta minus 2 times alpha beta by 1 minus of alpha plus beta plus alpha into beta. Now you see here it is not into plus is there, so small correction. Take the LCM and substitute all the values, we will get 1 by 12. Okay. So I hope that you understand these problems and you enjoyed today's class. With some more problems which were given in limits problems, tomorrow's class I will stand before you. So until then, all the best.